In this video I'm going to look at the binomial theorem, what the binomial theorem is, and an example of how to use it. So firstly, let's write down the binomial theorem and see what it looks like. If we take a binomial expression such as a plus x raised to an integer power n, then we can expand it as follows. It becomes n choose 0, the way you can choose 0 objects from n objects by a raised to the power n, plus n choose 1, the way we can choose 1 object from n objects, times a to the n minus 1, times x to the power 1, plus n choose 2 by a to the n minus 2 by x squared. So you can see that the powers of x are increasing and the powers of a are decreasing with each term. Now we can write out a general term, say the rth term down the sequence, and the rth term is then n choose r, or the number of ways that you can choose r objects from n, times a to the n minus r by x to the power r. That's the general term, or the rth term of the sequence. And the last term of the sequence, of course, will be the number of ways we can choose n objects from n objects, which is just 1, of course. And so that's n choose n times x to the power n, and that's the last term. So the expression n choose r objects can also be written as n cr. By definition, n cr is n factorial over r factorial outside of n minus r factorial. Let's have a look at an example of NCR, the way we can choose r objects from n. This example we're going to use 6 choose 3. And that can be written as 6 factorial over 3 factorial outside of 6 minus 3, or factorial. Quickly evaluating that now. We get 6 by 5 by 4 over 3 factorial. Will actually cancel out with the top, and so we're just left with 6 minus 3 factorial in the denominator. Pretty quickly see that 3 by 2 cancels with the 6, we get left with 5 by 4, or 20. Another way of writing a plus x to the n, we can write it using the sigma symbol. Sigma, the Greek letter sigma, means the sum of, and we're going to sum up the individual items from I equals 0 to I equals n of n choose I objects times a to the n minus I by x to the I. And that is the binomial theorem written as a sum. Let's look at an example now. Let's expand 3x plus 2 all to the power 4 using the binomial theorem. 3x plus 2 to the 4 we can write as sum from I equals 0 to this time 4, because our index there is 4. And we have 4 choose I objects in the sum by 3x to the power 4 minus I by 2 to the power I, whatever I happens to be. And I in this case will range from 0 through to 4. So the first term will be where I is equal to 0. So we have 4 choose 0 items by 3x to the 4 minus 0, which is just 4, and by 2 to the I, which is 2 to the 0, which is just 1. Next term, 4 choose 1 times 3x to the power 3. We reduce the power of x by 1 by 2 to the power 1. Next term, 4 choose 2, and the powers of x are decreasing, so it's 3x squared. The powers of 2 are increasing, 2 to the power 2. Plus next term, 4 choose 3 by 3 to the power 1 by 2 cubed. and the last term 4 choose 4, which is just 1 of course, by 2 to the power 4. Now we need to just evaluate those coefficients and collect the like terms. So 4 choose 0 is just 1. 3 to the power 4 is 81 times x to the 4th. 4 choose 1 is just 4. 3x cubed is 27x cubed by 2 to the power 1. 4 choose 2, if you can't work it out straight off the top of your head, we could think to ourselves, alright, that's 4 factorial over 2 factorial by 2 factorial. And if you quickly evaluate that, you'll see that comes to 6. So 4 choose 2 is 6. Times 3x squared is 9x squared by 2 squared, 4. Next term, 4 choose 3 is the same as 4 choose 1, so it's 4 by 3x by 2 cubed, which is 8, and 1 by 2 to the 4th is the last term. Just tidy that up now. You get 81x to the 4th plus 216 times x cubed plus 216 times x squared plus 96x plus 16. And that is the expansion of 3x plus 2, all raised to the power 4.